A recurring challenge I've encountered over the years is finding the balance between cost and performance for SQL servers that are used by front-end business teams. Business users always want more memory and compute, IT leadership always wants to minimize unnecessary costs, and usage of SQL servers by business end users can be cyclical and unpredictable. With Azure SQL Database, you can programmatically scale the memory and compute up and down, but how do you make sure it happens at the right time? Also, how do you do chargebacks to the teams that need extra juice for their SQL Server? This video will review a method for adding a Power Apps button that end users can push to turbocharge an Azure SQL database for a period of time. IT leadership can also control who pushes that button, when they're able to push it, the size of the scale-up, the duration of the scale-up, and using the button will also trigger a record that can be recorded and used for chargebacks to prevent abuse of that turbo button. This solution is a simple and easy approach to keep end business users happy, possibly reduce or at least control costs, possibly control your carbon footprint, and also store scale-up activity for easy and customizable translation to chargebacks. My name's Greg Beaumont. I created this demo and video based on feedback I've heard from customers over the years. If you like this video, please give it a thumbs up and follow the channel. So some of you might be asking, why would you want to give end users the ability to scale up an Azure SQL database with a button? Well, I think there's generally three groups of stakeholders that are involved. First, there's the IT engineering teams that are usually under constant pressure to keep costs down while also keeping the business happy. Secondly, you have the business users that want to get things done and they want to get them done quickly. So in general, they're always going to be in favor of more compute and faster performance. Thirdly, you have IT leadership that wants everybody to be happy so that they can have great business outcomes along with minimizing costs. So how does an Azure SQL Database button help with that problem? First of all, it could potentially lead to cost savings if you're able to keep your Azure SQL Database at a lower default cost or compute tier. So rather than keeping it at a higher tier, because usage might be unpredictable, you can take it down a notch and then just allow the users to kick it up for a short period of time when they need that extra compute. Secondly, business users will literally have a button they can push when they need to speed things up. So if their queries are taking a long time to run, if there's a bottleneck because it's the end of the quarter and the whole finance team is hammering the database, they can jack up performance and do it themselves by pushing a button. And then thirdly, you can use this method for chargebacks. Now, there are ways to get administrative level information on who's scaling things up and scaling things down. Generally, though, that's going to require some administrative API access. With this method, it's very simple to record who hit the turbo button, how long they scaled it up for, what they scaled it up to, and you could even add some custom fields to ask them why they had to do it. So let's quickly talk about what's happening behind the scenes. So a business user has access to a Power App. It could be in Teams, it could be in Power BI, it could be a standalone Power App, it could be in SharePoint. You choose where you want to put it. When they push that button, Power Automate will take the values that they entered for size and duration, pass them to Azure SQL Database, which will then scale up and keep a record of the details and the time and information about who did it. You can also use the app to find out what is the current state of the Azure SQL Database. So I'll walk through both of those examples in the demo. All right, so let's take a tour of the solution and dive into how it works. You'll see here I'm in Teams and I have a team for Turbo button for Azure SQL DB. And up at the top here, I have a tab for the Power App. Again, this could be a button inside of a Power BI report. It could be a standalone Power App. It could be in SharePoint. You choose where you want to put it. If I move down here to the bottom, I can click this button to find out what the database is currently scaled to. In this case, you'll see that it's a standard Azure SQL DB at the S2 compute level. Now, if we take a look at Azure SQL Database pricing, you'll see there's two different purchase models, the vCore model, which you could also use, but I'm using the DTU model. And what's nice about Azure SQL Database is you can pay by the hour. So scrolling down, this is for East US, and of course these prices are just representative of what was on the website on the day and time that I'm recording this video. But you can see at that S2 level, we're looking at about 10 cents an hour. If you move it down to an S1, that's going to cut the price by more than 50%. And if you move it up to an S3, it's going to double the price. And when you look over the course of a month, those numbers start to add up. And when you scale this capability across multiple databases, you can see some real savings. Especially as we roll down into the premium tier, you can see that there's the potential to save some big money on individual databases. And just to explain it, how would that work? Let's say that the majority of the time you just leave your database at a P4 because fewer people open tickets within your organization for performance issues and it seems to work really well. However, maybe you could scale down to a P2 or a P1 at night and be just fine. With this method, maybe you could leave it at a P2 and then allow users to scale up to a P4 or a P6 for an hour here or there when they need it. If I go back to the app, on the right-hand side, you'll see I also have the ability to choose a new service tier. So if I were to go ahead and scale this one up to an S3, and we'll do it for 30 minutes, click the button, you'll see that we also created a new entry here for that request. So you can see that I made the request a few moments ago to bump it up to an S3 for 30 minutes. Having done a lot of business intelligence in my days, I also added a date field and a time field to this table to make it really easy to build out a dimensional model and do some reporting on who's scaling up and when. You could also take this 30 minutes and multiply it by some sort of fee that you determine internally based upon your costs that gets charged back to the department for the person who pushed the button. If you don't do chargebacks, you do run the risk that users are just going to go in and push that button all the time because faster is always better. So having some level of accountability for that scale up, it'll give them what they need, but it'll hopefully incentivize them not to abuse the privilege. So what exactly happens when you push that turbo button? Here in Power Automate, you can see I have two different flows. The first is to get the status of the Azure SQL Database. Let's take a look at that one. You can see this was actually very simple to build. When a button gets pushed in Power Apps, it executes a SQL query to get the information about the Azure SQL Database, parses the answer, and then returns that information to the Power App so that it can be displayed to the end user. The second flow is the one that actually scales up the Azure SQL Database. If we take a look at this one, it does two things. First of all, when the button gets pushed in Power Apps, it inserts a row in the logs to record who pushed the button, what time they pushed it, how long they scaled it up for, and what they scaled it up to. In parallel, it's also going to execute a SQL query that specifies the service objective. In this case, it was S2, and that number's coming from the Power App. Then institutes a delay, which is also coming from the Power App. And then after that delay, it resets the Azure SQL Database back to the base service objective. If you wanted to, you could customize this to pretty much do whatever you want. You could have warnings sent out if something fails. You can have additional types of logging. The sky's the limit. So if you want to try this out for yourself, I'll put some links in the information below the video that point you in the right direction to go get started. Again, if you like this video, please give it a thumbs up and follow the channel. It would be greatly appreciated. And questions are welcome in the comments below.